the call, and all of that's going to be on our GitHub repository. So that's aka.ms/AKS Public Office Hours. So I'll drop that link in, but that's where you should go for the recordings. That's where we're going to link all the YouTube videos. That's where when we have updated invites, all of that's going to be kind of the source of truth. And then last but not least, if you have any questions, feedback, comments, or even just want to get involved and maybe present, feel free to reach out to us at aksofficehours@microsoft.com. And that's going to be the way that we kind of drive communication and feedback moving forward. So that's all I had. I'll stop talking now and pass it over to Dave.
All right, so we'll go through AKS updates first before the ecosystem updates. So some updates on AKS, some things that have gone GA recently is AKS managed Azure AD integration. If you're familiar with the Azure AD integration previously, it was a little convoluted to get set up and a little more complex. This is much more streamlined, so really check that out. If you're integrating with Azure Active Directory for your Kubernetes cluster. There's also integration with Azure Advisor now, so it'll give you like certain recommendations about your environment within AKS. There's also, if you're not as familiar with AKS, AKS provides a free managed control plane, but there's also an optional uptime SLA now that you can opt into for a minimal cost. What that gives you is a financially backed SLA and a specific SLA where the free version is just an SLO because you're not paying for it. So there's nothing that we can give you in return if we don't hit those SLAs. So it's more of an SLO in those terms. You can also scale down node pools. I can't really say node pools. So you can scale your node pools down to 0 now. Previously, you at least had to have one node within that cluster. So this will help you save some costs for specific type of workloads where you can scale down to 0. You will be able to, on the roadmap, there is an item to scale the cluster to 0. Currently, you still have to have a system node pool with at least one node in there. Some of the preview stuff, Azure Spot Instances is in preview and will go GA soonish. Azure Policy v3, which is based on the Open Policy Agent Gatekeeper project, that is in preview. This is really important for any of you that are using pod security policies within AKS because pod security policies will be deprecated. For utilizing Azure policy with those policies to provide the same functionality as pod security policy. So if you're relying on pod security policy, you should be taking a look at the Azure policy for AKS. Node image upgrades. This allows you to get a new kernel version. Previously, you would have to upgrade to a new AKS/Kubernetes version to get a new node image. So things like kernel updates. Now you can perform just a node image update where it'll only update those nodes. Also in previous application gateway ingress controller as a managed add-on. So whenever you create your cluster, you can define if you want the application gateway ingress controller at that time. Previously, this was something you had to go and deploy separately from your AKS cluster deployment. Also integration with Azure Resource Health. Giving you some more insights into the health of your cluster there. Firmware OS disk support. So this will be able to utilize the temporary OS disk when you from a virtual machine. It gives you a lot better performance and IOPS on that OS disk. So definitely something to look out for. And then also support for Ubuntu 18.04 and Containerd. Ubuntu 18.04 and Containerd will be the default going with, I believe, when we GA Kubernetes version 1.19. Then for just a few ecosystem updates, there wasn't a lot here, but those of you studying for your Certified Kubernetes Administration exam, this has been updated this month. So there's new objectives in it, and So you're going to want to take a look at that if you've been studying off the previous exam objectives. Also, interesting thing, Docker Hub has put in limitations on request here. So now if you do unauthenticated, it's 100 pulls per 6 hours. You start getting rate limited after that. For authenticated pulls, it is 200 pulls per 6 hours. So you should really look at if you're like pulling your base images from Docker Hub, things like that. You can see how this could be very limiting if you're in an enterprise organization. Luckily, none of us, majority of us aren't in offices anymore right now. So not as big an effect. But if you think you could be easily rate limited if you're going out of proxy and everybody's pulling images from Docker Hub. They also put in limitations around how long images will stay within the Docker Hub registry. So they will retire images after 6 months if they have not, those images have not been pulled. For CNCF updates, Thanos and K3s were added as sandbox projects. You can look at CNCF projects. There's sandbox. There's also like graduated. There's not many graduated projects. The graduated projects are things like Kubernetes, Prometheus, and so on. If you're not familiar with Thanos, essentially this provides you a high availability for Prometheus deployments. It also allows you to store your metrics long-term on cheaper storage, so you can actually send those metrics into an Azure storage account. It also gives you a global query view of all your Prometheus clusters. So if you are using Prometheus today, you should definitely take a look at Thanos. We have quite a few customers that run this in production. K3s is a slimmed down version of Kubernetes. They would say it's not a distribution. It kind of is, kind of isn't. But this is really the first kind of distribution that's been put into the CNCF project. So that's kind of interesting. Its biggest use case is around like edge scenarios where you have very limited compute, because it strips out a lot of the things that are not necessary within Kubernetes. Also, KubeCon EU sessions are now posted on YouTube. So if you didn't get to catch those, it was all virtual. All those sessions have been posted to YouTube. So there's a lot of great sessions out there. I think there was over 100 different sessions for KubeCon EU. So definitely take a look at those. Now we'll pass it over to Ray, who will be doing a deep dive on private AKS clusters.
Cool. Thanks, Dave. Thanks, Kendall. All right. Is that coming through properly? You see that? My slides?
Yeah.
Just started up.
Sweet. Okay. All right. Hey everyone. I'm Rico. I'm on the. This is the great when I have to follow my teammates because all I say is I'm on the exact same team. I'm an Azure Global Black Belt technical specialist. Essentially, what Dave and Kendall said, triple that. So let me get into it. So in this particular, our first kickoff, we're going to be talking about Azure Kubernetes Service, specifically around private clusters, and I want to also kind of rename private clusters. It's a little bit of a misconception when we actually deploy the actual advertised AKS private cluster. And I'm going to go in depth in terms of what is like a truly private cluster, or what people expect a private cluster to be. So first off, a shout out to Dennis Zilke, who's one of our GBB counterparts over in Europe, specifically Germany. He's got a great blog post on Medium that covers this in depth as well. So if you prefer a reference material or an article you want to refer back to at a later date, just type in fully private AKS clusters, and it'll show up as likely the first search result in your search engine. At least it was for me about 15-20 minutes ago. So private clusters, right? So we have a product called AKS Private Clusters. There's a document on Azure Docs called AKS Private Clusters and how to actually deploy it. That is a particular offering of AKS that does offer part of the full-on secured private cluster story. So what is in the AKS Private Cluster service when we deploy it? What it means is that the Kubernetes control plane, the AKS control plane itself, is not on, or it's not addressable on the public internet. So by default, if you were to go and just roll from the portal with like the minimal of minimal settings, or through CLI or through Terraform, the default way that it deploys is that the control plane is a fully addressable entity on the public internet with its own private IP address and a domain name associated to it, fully qualified domain name. And so that's the default mode when you deploy AKS. Now, if you choose to deploy a private cluster, I do quotation mark, that control plane is no longer addressable on the public internet, and it's only addressable over your private networking or Azure VNet and across the Azure backbone, networking backbone. And so it never escapes essentially any Azure data center itself. It doesn't traverse the public internet. It's only inside your VNet. And so that's what private clusters is. The way it does it is it leverages two additional technologies, private endpoints and private link, to essentially establish that connection within your virtual network. So the way it deploys is that your private cluster, your control plane itself, gets an IP address within the subnet that your AKS cluster is deployed into. So it looks like it's an entity inside your network. It's addressable through the IP address, but it actually gets resolved in the Azure Fabric itself to a managed subscription that Microsoft or Azure itself owns, manages and maintains for you, just like it would be on a public version. But all that traffic, all the packets being sent are over, again, the private backbone of our Azure network. So in that sense, that's what private clusters are. So it does have some dependencies on things like, again, private endpoint, private link, as well as a requirement to deploy the fully qualified domain name inside an Azure private DNS zone record. So those are the minimum things that need to be there. So when you plan accordingly to communicate to that cluster, one, any kubectl commands you're making have to be linked to your virtual network, meaning the command is being run on premises and it's being routed through private networking, either through a VPN connection, site to site, point to site, express route, VNet peering, if that's going on as well, across network to that actual address, and then it will resolve and hit your managed cluster or managed control plane cluster across the network. The other piece, again, is private DNS zone. If you are running a custom DNS server, there are things you'll need to have to set up in terms of DNS forwarding, etc. If you're using Azure DNS by default out of the box and it's associated to your cluster already, or rather associated to your virtual network, you're fine. There's no additional configuration in that sense out of the box. The other piece in order to create a fully secured private cluster is ensuring that your cluster itself, so the worker nodes rather, are being forced traffic-wise through some sort of network appliance, typically a firewall. And so this is more about securing the egress traffic out to the public internet. So your pods, if they're running, they're not just making random calls. You're going through the full security process to whitelist fully qualified domains or IP addresses or port ranges, etc., that are going to traverse across the public internet. So in that sense, the latter, or the second half of a fully private cluster, is setting up a load balancer with one of two types. So the default type is going to be outbound type of load balancer, and that's business as usual. Again, minimal setup in terms of your cluster, creates a load balancer for you. It'll attach a public IP address to that load balancer. And for all intents and purposes, your worker nodes, all your pods, etc., all that traffic goes through that load balancer. So whatever public IP address that load balancer has, it will appear that all those nodes will be coming from that IP address, the origin from the calls outward. So for most organizations, that should be okay in theory, but other enterprises, especially if you're in financial services or you're heavily regulated, you probably want the path where you're going to go through a network virtual appliance. So as a result, you're going to deploy a firewall, and you want all traffic to go through that firewall. In which case, you'll want to define a load balancer, or sorry, rather the outbound type of your cluster. Instead of being load balancer, setting it and defining it as user-defined routing. And so the requirements there are you have to have a firewall already pre-deployed, either with an IP address configured to it, or it knows to do a next hop to another appliance inside your network, whether that's on premises, whether that's still in your virtual network, etc. But it knows how to resolve where traffic that doesn't reside inside your virtual network will go on and be forwarded onto. And it also requires a user-defined route or route table associated to the subnet for your AKS cluster, or at least where your node pools are being deployed. That user-defined route or the route table sets the default route. So basically anything your virtual network doesn't know. In the case of being explicit, default route being 0.0.0.0/0, pointing it to the private IP address of your network virtual appliance, so a firewall. That way, any traffic that your network cannot resolve to, is not being published in terms of route tables, etc. It knows then to forward those IP addresses to your firewall, and then again, your firewall will handle where to resolve to next, if it's even allowed to. So those two pieces put together, again, private clusters plus a an outbound type for your clouds, an outbound type of your cluster to user-defined routing put together becomes fully private AKS clusters. Okay. So kind of walking through, I'm not going to do a full deployment because no one really wants to watch command line output. Well, what I'll do instead is walk through this kind of bit of an eyesore of a diagram, PowerPoint artist. So what we're going to take a look at first is the egress paths, the lower half, all the red line, how that traffic actually traverses through your network. And then we'll talk about quickly the ingress path, leveraging the firewall that you've already set up. So this, at a high level, again, is the full sort of private cluster plus outbound type setup. So again, private clusters, bird's eye view, this is what it looks like. You've got your control plane on the far right-hand side, circled in blue. That is all inside an Azure or Microsoft managed subscription, whether it's like 1 node, 2 nodes, 1 million nodes, that's on us to take care of, and that's why it's a managed service. The communication to that private cluster, that control plane, goes through a network card that is deployed inside your subnet, which is given a private IP address inside your subnet range, which then resolves or creates a private link to your control plane. So in this particular diagram, there's no communication outbound to the public internet, and the communication to your control plane is locked down secured. A note about the public model when deploying is that it can be done. The biggest difference is that you have to create public IP address whitelisting. So if you're communicating to a known set of IP addresses, if you're deploying your cluster with a public CIDR range, you can whitelist those ones, and only communication coming from that is allowed. You could also, and it's a lot more work to do, if you have remote workers in a remote world, as David mentioned before, you could whitelist individual IP addresses from like their home network, right? But that's a lot of work to do. Instead, what you probably want to do is set up VPN into your VNet and then have that communication already sort of assumed trust in that model. Okay, so that again is the private clusters, and again quotation marks. This is the default mode, deploying outbound type as load balancer. Again, my load balancer gets a public IP address, and a communication going out even to my control plane must go through the load balancer and over the public internet. And so this model may or may not be what you want. The egress, so outbound type of user-defined route. Now we're going to force traffic through a firewall or appliance. Again, we need 3 essentially key things here. A user-defined route, bottom right corner, this sort of gentleman here with an arrow beside his head. That defines a route table, which basically sets up the default route again to say any IP addresses or any ranges that we are not aware of in terms of the VNet. So typically things that are not within our CIDR range of our virtual network or something peered to us. Force traffic to the private IP address of the firewall, and that appliance will take care of routing going forward. All right, and then so that's the circle around this cloud of the brick wall. That's our firewall or network virtual appliance. That can be anything from an Azure firewall, an F5 appliance, Palo Alto. What you probably want to use is a next generation firewall, so you can do full like DNS based rules. But you could, in theory, send this off to like a pfSense box that you want to roll your own instead of using a marketplace solution, if you so wanted to. The third item, of course, there needs to be either an IP address or a next hop to another appliance. So again, if you want to directly leave your virtual network from the firewall, that firewall must have at least one IP address associated to it so that it can make communications out to the public internet. Or the next hop could be through ExpressRoute or a VPN gateway to some on-premises or another network tied to your Azure VNet. And that secondary network, that next hop in terms of the public IP address or the outbound routes could be from there as well. So how you want to set that up, that differs quite a bit from customer to customer, but this is typically a generic view of what this would look like. So tying that together, again, we've got in terms of our setup here, we've got a fully private cluster deployed. All of the communication to our control plane is through private networking, never escapes the public internet. Any communication to the outbound world must go through, again, the appliance of some sort. In this diagram, it's going to be an Azure firewall. That's totally up to you to decide what you want to do. So that's kind of tying together. In terms of the ingress path, the green line, the upper half of this diagram, ingress into the cluster must be going through the firewall. The reason being is that if you don't set it up in terms of going through the same appliance, there's some more work to do in terms of setting up asymmetric routing, because traffic coming in will come in through one IP address, and then when it leaves, it'll go through a different IP address. As a result of that, the firewall won't be able to know, if the traffic came in correctly, if it came in from itself or something else. It can be done, it can be accomplished in terms of setting up or fixing that asymmetric routing, but it's additional work. So in this particular case, we're just coming in from the same appliance that we're going out of. Traffic coming in from either a public domain name, it's going to be an A record or a CNAME record to that IP address, goes to the firewall, and the firewall will then set up a destination NAT rule to the private IP address of your load balancer. So it now becomes an internal load balancer that's fronting your cluster. And this would typically be associated to your ingress controller. In this particular diagram, I'm using Nginx, but it could be easily as traffic, HA proxy, you name your favorite ingress controller, but this would be kind of the standard setup as well. So the DNAT rule goes to the private IP address. The private IP address of the load balancer then will round robin it to one of the nodes in your cluster, which will then send traffic to ingress controller and resolve accordingly after that. So it's business as usual from that point on with your ingress controller. As we're seeing here. So then the traffic eventually makes it to your actual pod or your container or your specific workload as you need to. And yeah, you've got all the rules that you need to set up. This is again setting up that path there. I blew through that a lot faster than I have in previous sessions. So if there's any questions, I think I saw some stuff pop up, but that's all I have. So I'm ready for some Q&A if you've got questions about how private clusters are being set up. No, it looks like we got one. Sebastian?
Hey Ray, thanks for this. I'm curious on the private DNS zones. When I've used private endpoints in the private link service with other PaaS services, the different endpoints can all share a private DNS zone, where it looks like the private DNS zone for a Kubernetes cluster needs to be unique, at least to the region. Can you expand on the requirements around the DNS zone there?
Yeah, so the way that's being deployed now is that AKS isn't aware of any of your zones today, which is fine. It's not linking it to your virtual network, so it can't append the DNS record to your existing attached private zone. It'll just create a new one and make it available. So if you're already using Azure DNS, and this is what I mentioned before, if you're using Azure DNS, it's fine. It knows how to resolve to itself to figure out that endpoint. If you're using like a custom DNS server and have that linked to your VNet, so it could be a domain controller, it could be a bind9 server, you'd have to figure out how to set up conditional forwarding to Azure. So I always forget the address. It's 169, posted in the notes later.
Right, like the fake IP address that you only resolve from inside of Azure.
That's right. That's right. So if you've got that linked and you can do conditional forwarding to that service, then you should be fine as well.
Got it. Thanks.
Yeah. Alberto?
Yeah. Hey,
Hey.
so I was doing a couple of tests with Terraform and the AZCLI, and I wanted to kind of verify the order of operations, because when I do the base and I enable private link and then provision node pools after that, it seemed like some of them had a problem reaching the private cluster address. So I like to just clarify the order of operations would be, I would have to create the DNS zone first, create the cluster, publish it, and then create the node pools. Would that be the proper way?
So if you're deploying private clusters itself, depending on the version of Terraform you're using, the most recent ones will actually give you the property to actually enable private clusters. You don't actually have to do anything manually to enable DNS zones. That just gets created on your behalf when you deploy as a private cluster. So it gets made when you stamp down the cluster. So you can't, if you've already created a cluster that's not private cluster, as an example, you can't then upgrade that to a public cluster. So in that sense, there's no coordination. You can't just redeploy or add a DNS zone record for your control plane. You have to redeploy the entire cluster altogether.
Yeah, that I'm aware of. I think like I'm using Terraform 12, so I'm on the latest. I'm just trying to see, like, I did not see it auto provision the DNS zone, so I'll check that out. But in terms of auto, like the operation order, then Terraform should provision the cluster, the DNS zone should be created, and then everything should work as status quo, right?
Yeah, it should.
Okay.
Yeah, to your point in terms of seeing or not seeing a DNS zone, it gets deployed into the managed Kubernetes cluster. So it starts in terms of the resource group, it's the MC underscore whatever your Kubernetes cluster name is. So if you don't see it in the resource group that you, when you're defining Terraform in that RG, in that resource group that you deployed AKS into, it's because it's actually a resource inside the MC underscore resource group.
Okay, cool.
Yeah, it's fully Azure managed. So when you deploy it in that model, it's in the MC resource group itself.
Cool. Thank you.
Yeah.
Ray, are you able to see the chat, or do you need me to kind of give you some of these questions that are coming in?
Yeah, I can switch to the chat. Yep.
Cool.
So I guess there's a question from Tim. Any version restrictions on Nginx in the diagram you show? None that I'm aware of. If you're able to run Nginx in so the public mode of AKS, it'll work very similarly in terms of the private cluster mode. The only difference being is that you'd likely have to not likely you'd have to provision the load balancer as a private load balancer instead of a public one. But other than that, you can add those annotations accordingly. You can even manually allocate the IP address that you want to use within, if you're deploying the load balancer into a different subnet altogether. That's totally fine as well. So no limitations in terms of the Nginx version. Another question from Tim, where do you put TLS at the front end and then no TLS on the cluster? So the firewall itself won't do TLS for you. So that's still going to be business as usual, in my opinion, in terms of if you're going to put it in the Nginx ingress controller and do termination of TLS at Nginx or do pass-through, that's still a decision for yourself to take on. It all depends on if you want to do sort of full end-to-end encryption up to your application all through the public cert. So that TLS doing pass-through to the actual pod or the workload that you're trying to send traffic to. Or if you're going to do TLS termination at Nginx and you still want end-to-end, then you have to think about some kind of service mesh essentially to do encryption from Nginx ingress controller to your actual pod itself inside the cluster. So hopefully that answers your question, Tim. Another question from Jim Counts. Can you confirm that when we enable private cluster traffic to the control plane is also blocked? So private cluster traffic to the control plane is also blocked. It is not just that we gain a private route, but the public one is also closed. Oh, I see. Internet traffic. Yes, I see what you're saying. So yeah, so Jim, yes. So there is no public FQDN being published. There is no IP address associated to your private cluster. So yeah, not only is it explicit or exclusively over private networking to your control plane, there is no way to access your private cluster over the public internet either, because there's no FQDN to resolve. If you try to reach that address that's being published inside your virtual network in the Azure Private DNS zone, like if I just try to ping the address or try to run a kubectl command, it'll say that it can't resolve the domain name altogether. So you can't even reach it over public internet. Okay. Alberto, you have another question? Or was that from before? No? No more questions? Were those the, I think those were the only two, right? 2, 3?
Ray, I'll throw another one at you.
Yeah.
You kind of mentioned at the beginning, like private clusters. It's a bit of a misnomer, right? Because it sounds almost like a service bus premium namespace where you have dedicated hardware for your master node. I'm curious if there are plans that you can share with us that would lead to more isolation and kind of meet that private cluster name, or if private connectivity is kind of what the team is looking at right now.
I'm not aware of anything that gives you, you know, your own isolated rack or, you know, instances. That's still going to be as it is now. As part of the SLA, we do offer, you know, sort of multiple nodes in the control plane. But I guess at the heart of your question, no, there's nothing that I know of in terms of, you know, isolated hardware, isolated VMs on your behalf in that sense, in terms of the fabric. It's all connection based.
Great, thanks.
Yeah. Just as a note, you know, we'll cover the upcoming roadmap stuff in the call, just like Dave and Kendall did. But if you're curious in terms of what is coming into AKS, you can go to the GitHub repository. So it's github.com/Azure/AKS. And under projects, we actually publicly list the roadmap on there. So if there's an item that you're, you know, curious if it's coming out, that's a great way to check it. The other place that you can see if things are coming sort of from upstream AKS is to check out a project called AKS Engine. And that's what managed AKS is based off of. So if you wanted to roll your own, if you wanted to change the underlying host OS and other configurations, you'd use AKS Engine. At that point, it's not a managed service. It's really a IaaS++ template or script that you can deploy on your in your own subscription.
Yeah, and kind of going along that, I actually linked the roadmap on the GitHub page for these calls. So if you didn't catch that link, you can go there for that. And also, you know, if you have feedback or thoughts about, hey, we're trying to do something, we've attempted something, we really need a specific feature, this is actually a good forum, you know, at the end when we do the Q&A to just kind of discuss that with us. Because, you know, hopefully we can use this as a forum to also kind of communicate back to the PG around things that you know are in demand for customers or that people need. And so I do think there's a couple of additional questions for you, Ray. I don't know if you got a chance to look back at the chat. One of them, did you say we cannot make existing clusters private? I think that we did cover that, right? You need to provision a new cluster to do that. And then there was another one, will there be a feature to publish the private cluster IP to an already existing Azure DNS private zone instead of provisioning per cluster?
Yeah, so that is something the team is aware of. That, you know, you want to be aware of an existing DNS zone and be able to append to it. That is not necessarily the AKS team, but also like a networking team concern, because it has to go hand in hand with private endpoints, I believe it is, not just private link in terms of feature. And that is something other services like Azure SQL depend on as well. So yeah, that's something that is coming, but likely when we do switch to that, it will require you to redeploy the cluster. It's not going to be just like a toggle that you can activate on an existing cluster either. Do we have any reference architectures or info on healthcare FHIR servers in this architecture? I haven't seen any specific to healthcare in terms of reference architecture. We do have some that are being developed around financial services. There is a repository that Dave, on our call, Dave Strabel, and our team member Kevin Harris worked on in terms of a security and governance baseline cluster. And typically that's what we would spin off on, given your industry and other criteria you have. Yeah, Kendall's got it there, production baseline. Yeah, so that would be the starting point. Nothing, again, specific to any particular industry, although there are some internal documents around, financial services. But Tim, if you've got questions around healthcare, feel free to reach out to us. We'd be happy to, help you work through that as well.
Yeah, and I just dropped another doc too. I'm not sure how many of you are familiar with it, but the AKS checklist is a really good resource that kind of goes through some of the best practice considerations, especially from like a security perspective on ways that you would want to, implement certain features or functionality on top of your AKS cluster to really optimize the production experience. So yeah, I dropped that in as well, that you can kind of use in coordination with the production baseline.
Awesome. Thanks, Kendall.
So yeah, if there aren't any other questions, particularly around private clusters at this point, Dave and I will just open up the floor for general questions that you might have. So thanks, Ray, for the great overview. Really appreciate it. But yeah, so this time we just kind of want to open up the floor to anyone that might have questions around things that you're currently working on. I know that this will probably over time grow and become a little bit more regulated, but now, feel free to come off mute if you just have any one-off questions that we can help with.
Everybody's shy today.
Yeah, no takers.
So I will show one thing, because I planned on doing it during my AKS updates, and you mentioned it for the roadmap. So let me just share my screen here. Okay, so Ray mentioned the public roadmap here. So if you do go to this URL, github.com/azure/AKS, there's a few different things in here that are very valuable to really know about. One is going to be under the projects, the service roadmap here. So you'll see everything from that's been GA'd, things that are in public preview. As you can see, I only covered kind of the highlights, but there's tons of stuff out there in progress and planned. These are things that are typically going to be released to public preview within 3 months, where the backlog items here are typically a little further out sometimes. When you do have like feature requests, things like that, I always say use this issues here because our product team, as you can see, they do monitor this on a regular basis and will respond, and we'll get more information for you to kind of understand your use case. So there's also pinned issues. So if there's anything like, really important like CVEs and stuff, we also do pin those up here. The other thing to look at is releases. So anytime we release new updates or features within AKS, we put them under the release notes here. So you can see any type of fixes, important service updates, like, things that are going to change from the default behavior. Like I mentioned, when we go GA of 1.18, Ubuntu 18.04 will be the default for that. So this is a great place also to kind of see all the different release notes that we send out on features, bug fixes, any type of like image updates, those type of things you'll find here. So it's a really good resource to check if you want to look into the roadmap, suggest, new features, or just see what's been updated on a regular basis. This is a good place to go for that.
Hey Dave, maybe on that, just to further explain, if you went back to the releases, maybe explain what the process is like if you were looking at that in the source code and going, well, how do I deploy that into my cluster versus the auto image upgrade and how they're decoupled? That might be a good point to explain.
Yeah, so like these component updates here where we're updating base images here, that's where you can use like that node update or node image update feature. One of the things you'll find is, like I mentioned, that feature is in public preview, soon to go GA. Those type of things, you could do a node image update to get that latest release. We'll publish also in here, like if you have to upgrade to like a new Kubernetes version to get some of those features. Some of these features are just rolled out behind the scenes that you don't notice, especially things like fixes. Like a bug fix here. A lot of these things you don't have to perform any type of action to be able to get those bug fixes. They're pretty detailed in their release notes on anything that you would have to do, especially around the service updates. So definitely look at those service updates here. Typically your public preview stuff, there's a preview CLI. So within the Azure Docs, we always publish the instructions for public previews where you can opt in and you have to update your CLI typically. It's always good to keep the Azure CLI updated anyways, but you'll typically have to update your CLI and then you'll be able to utilize some of those public preview features. Public preview features are just that. They're not meant to typically be run in production. These are things that don't carry kind of support with them. That's not just saying we will tell you to leave, but you're not going to be able to open like Sev1 severity cases on something you're using in public preview. These things typically get set back to whatever the lowest severity is. So just be cognizant of that. Public preview things shouldn't typically run in production.
Dave, do you know if we have like a way to track the AKS deployments across regions? Like I know AKS charts kind of talks about what's available in each one, but that's not like real time. So I can't remember if we actually do have something that does that.
I think that's something they're looking at publishing. Because different regions have different features. Typically, you have to correlate that to in the Azure Docs. There's a lot of things that contain like, for example, availability zones. Not every region has availability zones, so you have to kind of correlate that to what's in that documentation.
Yeah, so I don't
in the release notes, we'll typically call out if it's for specific regions.
Yeah, and I know for some products we have, I mean, at least what I dropped in that Azure charts. That Azure charts is a really good resource that some people on the open source side of things in Microsoft have worked on. They have like the rollout map, which talks about like planned and published rollouts, but it's not necessarily like an AKS, like, okay, we've completed this region, we've completed that region. Next up is this region. So, but it's at least something, I guess.
Yeah.
I'm the one who asked the question. My main point is they do provide ETA for conclusion, but often this date always slip. Or so is there like a place we can get a real status of, okay, no, it's done, or it's been delayed, or versus always opening support to ask.
Yeah, I know this is something that like I was on the call with a customer and some people from the product group where they discussed a similar ask, and so we can at least take that back and see if there's anything like planned to actually make that a little bit more transparent. But I don't necessarily know if we have something right now, unless Dave, you want to talk.
Yeah, no, there's nothing right now. That's a good point, because when like a new release comes out and it says, hey, this is rolling out to all regions, it's not like it just rolls out to every single region at once. Typically, the process takes about a week based on the regions they start rolling out to. Then if there's any issues with those rollouts, it can end up taking longer to get to every region. So no, I think that's good feedback though, to have a little more insight to knowing when like these releases get to your region.
Any other thoughts or questions? Okay, well, before we wrap, just wanted to call out a few things. So I believe everyone here probably has access to the GitHub repo where we talk about future calls, but I'll go ahead and drop that again. Just keep in mind, we're going to be doing this bi-weekly, and we'll post on the AKS Public Office Hours GitHub repo about what the next calls will be. So the next one will be 2 weeks from now. We'll be covering Azure Active Directory enabled clusters, and then obviously any questions, thoughts, concerns on all of your end. And then I'll also, hopefully moving forward, we'll provide something on that GitHub repo where you can, once again, you can email us if you're interested in maybe presenting on a topic, but I also want to create a way to allow y'all to suggest topics. So, then we can kind of aggregate all of the feedback and the data that we get in to try to capitalize on a topic that, the most people will get benefit from. So appreciate everyone joining. Once again, definitely join again next time and share with your friends.
Hey, Kendall, before we drop.
Yeah, sure.
So just a quick mention, Microsoft is running the Ignite conference in a couple weeks. I think it's September 22nd, and there's a few Kubernetes sessions there. So if folks are interested, in fact, for those who joined us at the start of the call, they heard Dave mention his very popular AKS book. Well, one of the folks that kind of helped him out a little bit on that, Brendan Burns, is going to be doing a Ask the Expert session on AKS and Kubernetes. So, in case folks want to tune in and check that out as well.
Thanks, Jim.
Cool. Thanks, everyone.
Thanks,
Take care.
everyone. Have a great one.
Thanks everybody for joining.
Thank you.